Hi, Al the power supply guy here. Today we're going to talk a little bit about proper thermal management and your power supply applications. Let's go to the bench and take a look at what we have.
Okay, now we're over at the test bench here. I have a few things set up already. I want to point out the spec sheets here. Every spec sheet will give you clues as to the best way to apply your power supply, and often they'll tell you where there's a hot spot located on it, and that is what you should use to make sure your thermals are staying under the limits. These two models here are being way underutilized here, so they're not as efficient as they should be. Remember, efficiency is set up for 100% load. They want it to be the most efficient when it is fully loaded. So when you're at a partial load, you're going to get much less efficiency. In this case, we've got about 8 or 9 watts going into the main power supply here, and then you can see that's at 120 volts input. If you lower that, you'll find that you're drawing more wattage because it's less efficient at low line. However, I recommend doing your thermal testing at low line. That's when you're stressing the power supply the most, and you will find any weaknesses that way. Let's see. Now this is also powering this little DC to DC converter. Now, these guys are nice in that you can put a heat sink on this, or you could get one where you can stick it to the metal in your cabinet, or you can put more airflow across it if needed. In this case, I believe this model will go full output without having to be heat sunk. Now, a good rule of thumb is how hot is it when you're just testing it? Well, if you can hold your hand on it, at least with me, if I could hold my hand on it continuously, it is 50C or below. 50C is about the time where it gets a little painful. I don't recommend designing anything where the power supply is running over 60C continuously. If you have a spike in the day and somehow, there's times when it runs for a half hour, an hour at that temp, that's fine. But anything that's run continuously over that, it's just a pretty good rule of thumb. And this is our fan load here, and we're only drawing 97 mils on that. One last thing on this AC to DC power supply. The designs on how the cooling works varies greatly. In this case, the semis are located along this bar here, so you could sink this up against a piece of metal in 1U rack or what have you. There are two things you got to worry about: your your magnetics and your semis. In this case, a little bit of airflow makes quite a difference. And if you look at the spec sheet, it tells you this is the best direction for the airflow, and the others are slightly less effective. This is kind of the chart that shows you all the different inputs. We've got 8 watts in, and we're going to get 2.34 watts out. That means we have to dissipate that heat. That's 5.66 watts of heat. So that's your number in this case. And your DC to DC converter, it's taking 2.34 watts in, and it's putting out 1.16, and therefore you need to dissipate about 1.18 watts worth of heat in that case. And of course the fan is just our load. So there's a little bit about the thermals. Feel free to contact me with any questions.
Well, I hope that was useful. If you've got any questions, feel free to give me a ring anytime. Thank you much, and God bless.